Thank you, ladies and gentlemen. My name is called Anguyo from Uganda, that is East Africa. And particularly, I come from West Nile region, which is Rua. And Rua borders South Sudan in the north. And then in the west, we have Democratic Republic of Congo. Rua is one of the hubs for Uganda. It's one of the biggest capital city, if I can say. And for now, I'm doing my master's in immunology and clinical microbiology, and then working with the Muni University. And for me here, I really got interest into studying bats. That was way back in 2016. I went for a field expedition with Professor Diane and Mr. Emran, who introduced me, and then in the field expedition, we captured bats for study, and it was my first time, and that's where I got really interested. It really propelled me into understanding bats, because I didn't know at first that bats really have a lot of viruses, and most of these diseases which we are suffering from, especially like the COVID-19, the originality came from the bats. I didn't know, but I think that study really propelled me, and it has motivated me. I am right now currently into trying to study bats and understand bats. And from there, with my interactions with Professor Diane and the other people within the team, is when I propelled myself. I said, you know what, I need to study immunology. So currently I'm doing my master's in immunology and clinical microbiology, Makerere University. I'm in my final years. And for me right now, in this master's, when I started back in 2019, right now my research area changed into trying to understand bats. Currently, I am doing metagenomic analysis of coronaviruses from the bat fecal matter collected within Arua. We are trying to look at bat-human interface, and then when we, what viruses are they carrying? Are there real spillovers to come in? So this has really, motivated me, and I've done a lot in the research paper, and you will get to understand the results mostly when I'll publish this paper early next year, if God blesses and everything goes on. And currently, right now, for this short 5 minutes video, the paper I'm interested in is a paper which was published by Julian, Emran, Susan, Professor Diane. It's called Epileptic fruit bats display high levels of hepatocystis infection. And this is a study which was done in South Sudan. And when I looked back into that paper, it really touched me a lot. When we look at hepatocystis is it's a parasite, and it is close to the mammalian Plasmodium parasite, which causes malaria in humans. So, but what hepatocystis displays is that it doesn't have the asexual reproduction, which happens within the red blood cells, which is what we call the erythrocytic phase. But since it lacks that stage, it's not able to cause a lot of problems like what Plasmodium causes in humans. So, but for me, my interest right now is the liver stage where it develops. And then these bats are harboring it, yet there is high density in the bats within the liver. I think there could be something new coming up. At the immunology point of view, I think when we see parasite level is very high within the body, really, there are clinical signs which need to come up. Maybe there is something that we don't understand which is happening in the bats at the immunological point of view. Maybe the bats at the immunological point of view are doing something that we don't understand, that, it only happens there, but in humans it's not happening. So my interest right now is that if when we sit down, we try to read, we try to understand properly what immunological responses these bats are displaying that we humans lack. That's where it is touching me. Because, like, if you take like malaria, which is caused by the Plasmodium species, just +2, that's a big level in the human body, and is going to cause even a lot of morbidity or mortality. So, yet the bats are able to tolerate that high level of parasitemia, and then the parasite load also. So, this is what is motivating me at the immunological point. Right now, this paper, I'm looking at the immunological point. I want to understand the immunological responses that these bats are able to show, or they are doing, so that they are able to withstand this high level of parasitemia in them, yet without getting any disease. They don't get sick, they don't die. But for us human beings, as for a small thing like malaria, we just like cut off. So, as this region, West Nile, is harboring these bats, we really want to understand that these bats could be carrying that. There is something unique in their immune system that we don't know yet. For me, my interest is, let's creep into that. If at the retrocytic phase, they are not the red blood cells, they don't enter the red blood cells. Oh, they may enter, but they don't cause lysis of the red blood cells. Yet, their close friends, which are the Plasmodium, are able to, and then leads into manifestation of a lot of signs and symptoms and death. So I think spillover events may happen. Look at a mutation within the genomes. Maybe these parasites may mutate, and then at the end up causing a lot of things. So my interest is, this paper is a good paper. It opens our mind, and then it should be something that we need to look into, and then look at, so that we tackle everything. For me, the first thing at the immunological point of view I'm interested is, I want to see the profiling of the cytokines expressed when this infection happens, and then what different antibodies are produced by this. So this is where we can pick up and start a new thing. What I will say is just that when we come together, look at One Health, when we come together, build this thing, we may change the world. We may come to understand how we humans are able to suppress some of these parasites, prevent some of these infections from happening. I would say thank you so much, and may God bless you. And I look into new people coming in this area, and then we try to understand bats. Thank you so much.